Kim Shepard again. This is video 4H. We're going to take that 5-number summary from the last video and make a visual graph of this in the form of a box plot today. So box plots are great graphs if you want to compare the major measures of position for multiple sets of data. Here we've got home prices for houses in 2 different neighborhoods, and we can compare the median prices, you can compare the spread of the prices of those homes, and some other characteristics there by looking at box plots. Today we're going to be comparing 2 different box plots, but you could do this if you had 5 different neighborhoods. You could have 5 different box plots, and you could be comparing those measures of position for each of the 5 neighborhoods. Okay, so to construct a box plot, you first need that 5-number summary that we talked about last time. We need the minimum observation, Q1, Q2, Q3, and your maximum value. You'll use that to figure out if you have any outliers in your data set, because we're going to visually see those in our box plot. And essentially the steps that we'll do is that you're going to draw a box. That box is going to start at Q1 and go up to Q3. We'll draw a line inside the box where the median is. Don't draw that line necessarily in the center of the box. The median is not always just right in the middle of the box. We'll draw the median where the median exists. After we've constructed the box, sometimes box plots are called box and whisker plots, because now we're going to draw little whiskers that extend from the box. Those whiskers are going to extend to the largest and smallest observations in your data set that are not outliers. A common mistake when you draw these by hand is to draw those to the value of the fences. Don't do that. The value of your fences are not necessarily data points. You're drawing them to the smallest and largest observations in your data set that are not outliers. And then the last thing that we'll do is we'll mark any outliers with either a dot or an asterisk. Okay, so let's go ahead and do this. Last time we looked at ages of Cecil College statistics students, and we did this for a group of female students and a group of male students. And today we're going to construct the box plots for those. So we did a lot of work where we did the 5-number summaries, figured out what the value of the fences were, and if we had any outliers. So I'm going to take this information from last time and now construct 2 box plots, one for the females and one for the males. We'll start with the females. For the females, the first thing that I'll do when I construct my box plot is I'll draw a box. The box will start at Q1 and go up to 27.5. So I'm going to come over here, where I've drawn an axis here vertically. And I said that Q1 was at 19, so I'm going to come down to right about 19. And that's going to be the bottom of the box. Q3 was at 27.5, so I'm going to come up here to 27.5, draw the top of the box. And that's the box part of the box plot. Again, this down here was Q1, this was Q3. The median of this set of data was 20. Again, don't just put the median there. That looks like the median's like 25. The median was very close to Q1. The median's way down here. Okay, now for the whiskers. On the lower end, the smallest observation that we had was 18, and 18 was not an outlier, and so I will draw a little tiny whisker there, and that's going to extend down to 18. Sometimes you'll see a little line drawn like this, but this is going down to the smallest observation because that's not an outlier. For the whisker on the top end, we did have some outliers. So I'm not just going to draw that whisker all the way up to the largest observation, which was 47. 47 and 45 were outliers. And in that set of data, the next largest observation was 40. Now the upper fence is 40.25. I'm not going to draw this to 40.25. I'm drawing this to 40. You're barely going to notice a difference here, but sometimes you will. So this is going to go up to 40. Which was the largest observation that was not an outlier. And then we had 2 outliers. One was at 45, so I'll denote that with an asterisk or a dot. and the other was at 47. And so that's what the box plot would look like for the set of female data. If we come over and draw the box plot for the male data right beside this, we'll be able to compare the two sets of data as far as their 5-number summary goes. So for the males, Q1 was at 19. So yeah, Q1 was at 19, which was actually the same for the female. So this is going to start at the same place that the female box plot did. And Q3 was 22. So if I approximate about where 22 goes, it's about right there. So again, this is Q1, this is Q3. The median for the set of male data was 19.5, so just barely above 19 there. And then the smallest observation in the data set was actually at 19 as well. So Q1 and the minimum value, they're both down there. They're both 19. There is no lower whisker to this. If we look beyond Q3, if we look back at that data set, there were no observations that were larger than 22 that were not outliers. There were 2 observations that were larger than 22, but they were both outliers. 27 was an outlier, so right about there. And then 56 was an outlier, so he's way up here. And that's what the box plot for males would look like. And now you can compare, and you can see that the ages of the males were a lot more compact here, aside from those couple of outliers, than they were for the females. And we can compare other attributes about this. They actually had the same Q1. Their medians were close. And again, we're comparing 2 groups, but if you had something where you had 4 groups or 5 groups, you could certainly have multiple box plots, and you could compare those. Okay, let's return to the board. One thing to be careful of, histograms and dot plots plot all of your data. Box plots are only based on that 5-number summary, so you do have to be careful when you want to talk about shape based solely on a box plot. This is the same set of data. The histogram here, you see that heights are actually bimodal. There are 2 peaks, but you lose that by looking at the box plot. You can't see the fact that the data are bimodal. So if you want to talk about shape, look at a histogram. But box plots are really nice if you want to compare a couple of groups of data. Okay, let's talk for a second about outliers. Sometimes the outliers in a data set are some of the more interesting cases, but how you deal with them is important. So if the outlier rule of thumb identifies outliers, it tells you that they exist, but it doesn't exactly tell you what to do with them. So just some caution, some things you don't want to do. We don't want to silently leave an outlier in place and pretend as if there's nothing unusual about it. So don't do that. For one thing, you want to check and make sure, is that outlier a typo? But we don't want to just silently ignore it. You also just don't want to say, oh, I've got some outliers, I'll just drop them from my data. So don't just drop them from your data without comment there. If an outlier is simply unbelievable, perhaps it's an incorrect response. If we had had an age of 143, I don't think there's any 143-year-old statistics students, we would probably drop that from the data set. So investigate if you have some numbers that seem unbelievable and correct them if you can. Sometimes maybe you transpose a number. If there's no way to correct the value, then oftentimes the best path is to run the analysis both with and without the outlier. Okay, last example. In 1961, Roger Maris made baseball history by hitting 61 home runs, beating Babe Ruth's 1927 record by 1. And so here are Maris's home run totals for his 10 seasons. And we would like to figure out if his record-setting year was considered an outlier. So here are the data. I'm going to quickly summarize over here our 5-number summary. The smallest observation is 8. The largest is 61. The median value would be the average of 23 and 26, which would be 24.5. And Q1's 14, and Q3 is 33. I think you should be able to verify those. Okay, we're predominantly interested in if that 61 is an outlier. So I'm going to go right to the computation of fences. We need the IQR. If you look at the difference in the quartiles, the interquartile range for this data set's 19. And so the upper fence, if we use our formula, take Q1 and add 1.5 times the interquartile range, is 61.5. I'm going to leave it for you to verify that the lower fence is actually a negative 14.5. Clearly there's no outliers on the low end. Ironically, 61 then is not an outlier. 61 home runs is not more than 61.5. And so the box plot for this, we'd start at Q1 at 14. We'd draw a box that would go up to 33. The median is 24.5. The smallest observation is 8, and it's not an outlier. And the largest observation is 61, and technically not an outlier. So this is what the box plot would look like. This one's a nice one though, like don't forget about your common sense. 61 was still a record-breaking year. Just because it's statistically not an outlier here does not take away from that fact. So, you know, box plots are great. The outlier rule of thumb is helpful, but don't forget about common sense here. That was still a record-breaking year. That's it.